Would you please state to the camera your full name and occupation?
My name is my name is Lew Harriman, and for some 35 years I was an active consultant in the area of humidity and moisture control in buildings, and therefore I spent a lot of time thinking about building enclosures as a result of that.
Wonderful. And what are the results of the thinking? Did you come up to any conclusions?
Yes, I think a couple conclusions. One is that air barriers are extremely important in terms of humidity control, because the big problem that we have in humidity control is the load, and the load consists of two things: the ventilation air, which in theory we can control with the HVAC system, and the air leakage through the building, which we we can also influence with the HVAC system. And for those on the mechanical system side, thinking about the building enclosure, one thing that you can do to ensure that the building enclosure actually behaves as it should is to make sure that the ductwork, the HVAC ductwork, is in fact air sealed and tested and measured to be air sealed. Because if the ductwork isn't sealed, if there are open plenums, if there are return air plenums that have corners that really aren't attached, which is very, very typically the case, then the HVAC system is going to create pressures on a continuous basis that the wind probably will never equal in terms of the humidity load. It's going to suck in humid air, and it's going to suck in dry air in the northern climate in the winter. So humidity control is going to be extremely difficult if the HVAC ductwork is not airtight. And it's not the ductwork so much as the joints. What you really want to think about is you want to think about the connections where the ductwork meets the air handlers, because that's where the pressure is greatest, is at the entrance and exit of the air handler. So that's a great place for mechanical engineers to think about. It's a great place for architects to think about in terms of asking this question of the mechanical engineer. Is what are we doing to ensure that the ductwork integrity is tested and ensured to be leak-free at the entrance and exits of all the connections of the ductwork? That's my takeaway from 35 years of thinking about the building enclosure with respect to HVAC.
And you are also an accomplished author. I have a book about humidity in buildings on my shelf, which I actually use quite often. You are a co-author, I believe, of this book. So you are involved in research and development. Is that true?
Yes, involved in research and development, and I think what you're referring to, Kaz, is the books that many of us have gathered together to write. I certainly was a project manager for the books, but it's the result of a collaborative effort, largely by the members of the Building Moisture Investigation community, and especially the members of ASHRAE Technical Committee 112. Technical Committee 112 is moisture management in buildings, and that's been our charge since 2001, if I remember when we were founded, in response to the mold problems. And the first thing that we did is gather together experts to for the first time in ASHRAE, have a dedicated book on the subject of humidity control. So that's the ASHRAE Humidity Control Design Guide. That was the first major effort. It's about 512 pages. It talks about a lot of different applications, specific applications, and also the general principles, and also shows some examples of what's not a good idea to do and reasons why. The other thing that TC Technical Committee 112 has done is publish chapters in the ASHRAE Handbook, specifically in the ASHRAE Handbook of Fundamentals, just updated recently. And in that chapter, in the Fundamentals, Moisture Management in Buildings, we talk about the typical problems that happen in buildings with respect to moisture and mold, and how to avoid those from a design perspective and also from an operational perspective. So yes, you could say that I've been an author, and I've certainly done a lot of the writing, but the information comes from not just me, but a lot of other people. And I think the thing that we're probably most proud of is the fact that we have a standard For the design of ventilation systems, ASHRAE standard 62.1, and the moisture group was able to effect a very positive change 3 years ago in 2019. And that change is an important one in that it gives designers a maximum level of humidity with which to judge the dehumidification effectiveness of their system. And that is that if the dew point in the building is kept to a maximum of a 60 degree Fahrenheit or a 15 degree C dew point, and if the system is designed to make sure that that happens even during unoccupied periods, as the standard requires, then that's going to be very, very low risk for moisture and mold problems in buildings. If there's no attention paid to maintaining a maximum dew point, a maximum total mass of moisture in the building, in the air rather, then that's where we've been able to see a lot of problems over the last 50 years. So if we can stop thinking so much about relative humidity and think more about the dew point temperature of the air, the mass of moisture in the air, that's going to be a real advance in HVAC design and also in the success of the building enclosure over time.
Wonderful. Thank you so much.
Sure, you bet. You bet.